Hi everyone, welcome back to Innoskrit. So let's solve today's daily LeetCode challenge, which is sum root to leaf numbers. So let's try to read the problem statement first. So we are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path is the tree represents a number. For example, the root to leaf path 1 to 3 represents the number 1 to 3. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer. A leaf node is a node with no children. So let me just clear this problem statement. So let's see one example. So here I have taken one tree. So what the problem statement is saying that each root to leaf path represents a number. So each root to leaf path, just look at this path 3 to 9. So this represents a number. Then 3, 4, 2 represents one number, and then 3, 4, 5 represents one number, right? So these are three different numbers. Now we need to sum them, right? So if I sum them together, so what will happen? 6, then carry 1, 2, then carry 1, and 7. So this should be the answer, 7 to 6, right? Great. Now this is what we have to return, right? So the question is very simple, right? What we need to do is we need to somehow traverse this entire one path. We will keep on calculating the current sum for this particular path. Say for example, initially it would be 3, then it would become actually 39. Now once we have covered one path, we will try to return this particular sum from here, right? So 39 would be here. Now we will try to traverse this particular path. So initially the sum was 3, then we will come to this node, it would become 34, then we will come to the left, it will become 3, 4, 2. Right, and once we come over here, because this node is the leaf node, so what we will do, we will try to return from this this particular sum from here, right? So eventually this would be 3, 4, 2, then we will try to cover the right path, and it would be 3, 4, 5, and we will try to return 3, 4, 5 from here. Now when we get the left value and the right value, what we will do, we will sum them together and we will return that particular value, right? So we will sum them together, let's say it would be x, and then we will return it from 4. And now finally when we will come to this 3, and 3 would be returning two answers to someone else, so we will return 39 plus this particular x, right? So let's see how we are gonna do it, right? So initially we are at the root node. What I'll do, I'll take a sum value which is initially 0, right? And I will try to apply this formula. Sum is equals to whatever sum you have calculated so far for the current path into 10 plus the current value, which is root dot val. So I will try to apply this particular formula. Let's see. So initially you are at the root. This root is not null, right? This is something. This is non-null value. So what I will do, I'll come over here. I will say, okay, what is the current sum so far? It's 0 into 10 plus the current root value, which is 3. So if you just solve it properly, it would be 0 into 10, 0 plus 3, and eventually you will get 3. Okay, so now the sum has become 3. And okay, if you have processed this particular node, just make sure that you come to this left value if it's there, right? Because the left value is not null, so you come to this value now. And once again, the current value is not null because it's not null, so you again apply this particular formula. So what you will do, you will say, okay, sum into 10 plus root dot val. And now just see, this time sum is 3 into 10 plus the current root value, which is 9, right? So this would become 30 plus 9, and eventually this would become 39. Okay, so now your sum has become 39. I hope you are getting this point, right? Great. Now once you calculated this sum, you are gonna return from it here, because this the left and right for this 9 are actually null, right? Is 9 ka left and right null hai, because it's the end node for this particular path. So what you are going to do is you are going to return 39 from this particular path, right? So what you will do, you will say, okay, just return 39 from here. So you will return 39 from here, and because you are returning value, you will again come back to this root node. Okay, and when you come back to this root node, the sum was 3 actually, right? If you remember, see, when you were at this 3, you calculated sum 3, then you move to the left, then your sum actually became 39, right? Okay, because now you are coming back to the previous state once again, right? When you were at 3. So when you were at 3, the sum was also 3, right? The sum was also 3 because it's a variable that you are taking within a function, right? So you called this particular function to 9, the sum became 39, but when you are coming back to this root, the sum was 3 at that point in time, right? So now you will start processing this particular tree from the right side. Okay, let's do that, right? So when, let's process it. Okay, so now from 3 to 4, from 3, you will come to this 4, right? You will come to this 4. And when you will come to this 4, this is a non-null node. So now you will calculate the sum. So let's calculate it. So this would become 3, the current sum, into 10 plus 4, which is 30, and plus 4, 34, right? Great. So now sum has become 34. Nice. Now once again, when you come to this, okay, you are at this node now. Now when you are at this node, again you try to go to the left. So you will come to this node, which is 2. And now once again you will calculate the sum, because this current node is not null, right? So the current sum so far is 34 into 10 plus the current root value, which is 2. So this would become 340, and plus 2 is nothing but 342, right? So your current sum has now become 342. Okay, and now just try to look at this now. This current root node has, or basically it's a leaf node, right? If it's a leaf node, just return the value from here, right? Just return the value from here. So what you will do, you will return 342 from here, 342 from here. And because now you are returning, you will once again come back to this root node. And when you were at this 4, you already calculated the sum at this particular node, which was 34, right? And once you are over here, now what you will do, you will try to make a right call, right? You will try to make a right call. And when you will try to make a right call, you will come to this 5. You will come to this 5. And what you will do, the sum was already 34. 34 into 10 will be 340. And the current root value is 5. So when you will add this together, so this will become 345. And because this current node is a leaf node for this particular path, so now what you will do, while returning from this 5, you will return actually this particular sum that you have got so far, right? So you will return 345 from here. Okay, and now you will come to this node. Okay, nice. Now once the left or right part of any node is done, right? Once the left or right part of any node is done, you will sum them together, like you will sum them together and then return back, right? So now while returning from here, you will return the sum of both the values, right? So this would become basically 6, 8 and 7, 687. Okay, nice. And now once again, somebody has called this particular function, right, to calculate this, right? So maybe from the main function, you must have called this particular function to solve the entire process, right? So what will happen from this root node, like somebody has called this function on root node, right? So this will also return the sum of both. So 39 plus 687 would be nothing but it would be 726, right? Nice. So I hope you have understood what I'm trying to say or what I'm trying to explain, right? So let's try to code this together and then maybe you will get it, right? So what I'm saying is, okay, just return solve from here, passing this root node and passing sum as 0 initially, right? And now let's make a new function which will calculate this for me, right? So we are passing root node, right, and sum. Now I would say simply, if root is null, just return 0, because we cannot return anything, any sum, if the root is 0, right? If root is null, return 0. But if otherwise, if root is not null, so just calculate the sum. So sum would be nothing but sum into 10 plus the current root value, right? So just keep calculating the sum so far. Okay, and we need to convert digits into numbers. So you have already read this particular thing, how to convert digits into number, right? So sum into 10 plus root dot val. Now just check if the current value is leaf node. So if root dot left is equals to null and root dot right is equals to null. If current node is the leaf node, just make sure that you are returning sum from here, right? This is what we need to do. Otherwise, what we will do for the current node, whatever we will get from the left and whatever we will get from the right? Because eventually we are getting sum only, right? Just see, eventually whenever you reach a leaf node, you are returning sum only, right? And if you are returning sum, so whatever you will get from the left side and from whatever you will get from the right side, you just need to sum them together and then return back to the current node, right? So what will happen? Return solve root dot left comma current sum, just pass the current sum, plus solve root dot right and current sum. This is what we have to do, right? And this is it. Just try to run it and it's accepted. Now let's try to submit this and it got submitted, right? So it was very easy, right? So this is it from my side for this video, and I'll see you in the next video. Till then, bye bye.